Hello. Hello everyone, and first let me know if you guys can hear me. Okay, I will also check on my phone right now, and let's wait for a few more people to join in. Hello Sharad, hello Saurabh. Hope you are doing great and stay safe in pandemic. Okay. Everyone, and first let me know if you guys can hear me. I will also check on my phone right now, and let's wait. Okay, I guess we are like the audio is proper, and let's start with the stream. So first of all, yeah, I know I've been offline from YouTube for a long time. Okay, I haven't uploaded any videos from past 1 or 2 months, I guess. But the reason behind that is very valid. Okay, and that's the reason I am live today to show you all that what I've been working. Me along with my team have been working for past 1 month. Okay, and this was all for you guys because I got many requests regarding the same. Hi Tushar, hi Gokul, thanks bro, but I haven't explained what it is yet. So yeah, so many of you guys on my YouTube comments and even on my Instagram, you were telling me that you wanted to build a robot, a ROS robot, but you didn't have money, or you wanted to test your algorithms, but you were not able to invest heavy amounts into making robots. So that's the reason me along with my friends at RigBetel Labs, we have developed a remote robot lab for you guys, in which we will be introducing Tortoisebot, which is a clone of a Turtlebot, but in a very efficient way. And you can access Tortoisebot from anywhere in the world using this virtual playground. So in today's live stream, I will be showing you how you can book an appointment for Tortoisebot playground and how you can access it. Okay. So Kushagra Singh, is it free? Yes, Kushagra, it's free for a couple of days right now. We are having the early bird offer, so you can access it totally for free. Okay, and it's going to be very cheap. Okay, it's going to be like 39 or 40 rupees per hour. So you can definitely, it's not that expensive. Bro, please tell my best and useful project. Okay, because when I make different projects, I always think what the project can do. Okay, so you can always check out on internet if there are any such projects, and you can always find inspiration from internet. I hope that helps to share. So let's start with this Tortoisebot playground. So the first thing that you need to do is go to RigBetel Labs. Okay, you can search it over Google and you will find the website of RigBetel Labs, or you can just go to rigbetellabs.com. And once you land up on this website, there you have the pop-up of Tortoisebot. Okay, so you can directly book a appointment from here. So here it tells that there's a limited time offer, so you can book your slot from here. And once you go over here, it will ask to book some it will ask to book your appointment from date and time. Okay, so let's book an appointment on 18th April, which is now, and 10:15. Okay, I will book an appointment and I will put up my details. If you don't want to put up these details again and again, then you can sign up on the website, or else just like you can enter as guest. Okay, so I will I will put my name here, Pranshu Tople, and I will put my email, which is pranshutople@gmail.com. Okay, and I can put my number 8983592752, and I can schedule my appointment from here. And it tells you that the appointment has been booked. It's that simple. Okay, you don't have to do anything else. Your appointment on this given time on and date will be booked automatically. And once you book that, you will get an email on the email that you gave over here. Okay, so let's check my email. So there you have it. I got a mail which says, hello Pranshu Tople, and thank you very much for booking free trial of Tortoisebot playground. So in this mail, you will be given the Zoom link that you have to join from your PC to access Tortoisebot remotely. And apart from that, there is also documentation that you can go through before joining the session. Okay, so this documentation consists of complete details about Tortoisebot Playground, what are all the commands that you can run into it, and it's a really great walkthrough of the Tortoisebot Playground as well as details about Tortoisebot. So definitely go through it. So we will see this when we will actually implement Tortoisebot. So now let's do one thing. So we have appointment of 10:15. So we can just join it through here, and I will start the Zoom link. Okay. It's recommended to join a little bit earlier, okay, so that you don't miss anything. So it says please wait for the host to start the meeting. Okay, so let's wait. Until then, let's check out what all others are saying on the chat. Thanks Gokul for responding that yeah, it's the trial run is going on, so it's free, and we have been giving free for like total 100 peoples, and I guess we have already crossed 50 plus peoples, 50 plus bookings. So if you want to get into the free trial, register or book an appointment right now. Okay. Personally have used this and was really amazed by the results. Recommended everyone to try it out once. Thanks Jatin. I hope everyone just like you, everyone else like it too. Apart from that, is there anyone else? So yeah, so this was the thing that we were working on from a pretty large time. I will just show you the robot, the Tortoisebot. So this is the robot that I've been working on. You can see it's like a complete, it looks very alike to Turtlebot. And yeah, so we are also planning to sell this as a kit for other peoples as well. But right now you can try it out. If you like it, then you can totally buy it. So it's like pehle istemal kare fir vishwas kare. So it's definitely worth it. Okay. Are you planning to make any ROS, any projects with ROS 2? Yeah, so we are also planning to integrate ROS 2 on this robot later on. I will just give you a brief of this robot. So this robot has DC motors at the base along with a battery, which is a 12-volt battery, and we have a motor driver in between along with some power conversion unit. And then it has a Raspberry Pi 4 4GB with a 4GB RAM, and also a Raspberry Pi camera in the front. Okay, and apart from that, we have a YD LiDAR X4 at the top. That's it what this robot has. And if you want to know more details about this robot, you can check out the Instagram page of RigBetel Labs, or even you can follow RigBetel Labs on LinkedIn. Okay, so okay, so let's start with the appointment. So this Tortoisebot Playground is, you can consider it's more like free for next couple of days only. So please book your appointment right now. It will be very much like even your feedback will be very constructive for us as well. Is it Orange Lipo 3S? Yes, it is Orange Lipo 3S. So yeah, it's 10:15 and we have started the meeting. So let's see if you guys can see this. Yeah. Let me full screen it. Yeah, so there we have it. So once you join the Zoom link, you will be able to see this Tortoisebot Playground, okay, which is the real robot which is just placed over behind me, okay, and you will be able to see yourself as well. So what you can do is there will be an assistant or instructor along with you on the Tortoisebot Playground. So he will be guiding you through the complete scenario. So right now Shubham is handling that. So Shubham, can you share your screen? Yeah, so the instructor will share his screen. I guess it's not visible on the live stream. Just wait, let me check. Yeah, so you will get a view of a Zoom meeting like this. But what you can do is on the top right corner, you will see an option which says view, and you can select that view option and then click on side by side speaker or side by side gallery, anything you wish. Okay, so let's keep it side by side speaker, and I will also like make this as a small window instead of the complete window. Shivam, can you stop sharing a screen? I guess it's lagging right now. Can you please stop sharing that? Okay, thank you very much. Just wait a minute. I guess there is some issue in sharing Zoom meeting link. Let me check. Maintain current side. Okay, I guess it will be able to. Yeah, now it's better. Shivam, can you share the screen now? Yeah, it's better now. So once you select the view as side by side from the top right corner over here, so now you can see you can simultaneously see the desktop as well as the view from the camera. Okay, and you can scale it like this. If you don't want to view yourself, you can right click and then select hide self view, and this way you can only access the camera and the screen. Okay, and the instructor who will be alongside you on the Tortoisebot playground, he will be giving you the remote access of the desktop. Okay, so you can grant the access of remote desktop. So Shubham, can you please do that? Yeah, thank you very much. So now I can control this screen. Okay, so if I click over here, then I can scroll the page. Okay, it's all mine. It's like accessing your own PC. I can just select some text over here. I can do anything that I want. If you wish, you can also view it in full screen, but it completely depends upon you. Okay, so during this session, if you are doing it for first time, I would recommend going through this guide and following this guide along, because this includes some beginner projects like autonomous navigation, mapping, and also teleoperation and camera view. So you can definitely watch those so that you get a brief idea of what Tortoisebot exactly is, and then later on you can book anytime else that you are comfortable with, and at that time you can make your own algorithms, you can make your own code and try it out on Tortoisebot playground. Okay, so let's start with the complete thing. So I will just click here once again, and I will scroll down a little bit. So first thing we need to do is to like connect our computer to the robot. So the robot is running Raspberry Pi, as you told before. So for connection between the computer and the robot, we need to SSH into the robot. Okay, so let's do that thing. So I will select this command which says SSH and pi @ the IP address of the pi. Okay, so and you will also have access to all the terminals, and you can put the command over here. If you wish, you can start up a new terminal and start from scratch. So it's the terminal over here are terminator. So the good thing about terminator is you can split terminals into multiple terminals. I can extend it like this. I can right click and I can split vertically, and I can even resize these terminals. Yeah, so first I will SSH into pi. So I will right click and paste this command which says SSH pi @ the IP address of the pi, and I will press enter. Okay, it will ask for password. and even the password is given in the documentation, which is contrast. So I will just type in contrast. And if you're using Linux for first time, again, if you type anything in password, it won't print on the terminal, so don't get freaked out. Just type it and press enter. Okay, now here you will be greeted with pi@raspberry. So what does it say is it's actually telling that you are connected to Raspberry Pi. Okay, I will just increase the font size so it's visible. How are you? Yes, I am great. I'm doing great. I've been busy working on this Tortoisebot playground, and that's the reason I was not active on YouTube. Okay, so I hope this is completely worth it and you will like what I've been working on since this long. What are the advanced robotics challenge a master's or graduate advanced robotic engineer can participate? So there are many robotics competitions, such as there are some competitions by DARPA, there are some competitions by NASA. You can definitely join into those, and even ROS itself hosts some hackathons for agriculture as well as few other domains. So you can definitely participate in that. I hope that helps, Chaitanya. Okay, so now let's get ahead. So once you are booted up into Raspberry Pi, I will scroll it a little bit more, and let's start with the simulation. Okay, so if you are controlling a robot for the first time, it's recommended to use a simulation, get a gist about the controls of the robot, and once you are familiar with those, then you can try it out on a real robot. Okay, so for that, here the Raspberry Pi is our master, so we need to run ROS core on Raspberry Pi. So I will open up a terminal. This is the terminal of Raspberry Pi, and I will paste the command over here and hit enter. This will start up ROS core. The next thing you need to do is launch up the simulation. So this simulation can be launched anywhere, even in Raspberry Pi or in desktop PC, but it's recommended to boot it up in a desktop PC because desktop PC has more processing power than Raspberry Pi, so it's easier to load everything in the simulation. Okay, so this terminal belongs to the Ubuntu PC that we are connected to, so I will paste it over here and I will press enter. So let the simulation load completely. Is it an orange LiPo 3S battery? Yes, it is an orange LiPo 3S battery, Chandan. So here in the camera you can see only one view of the robot. Okay, you cannot see what's behind or what are the other symbols like other signs that are there in the arena. But using simulation, you can view the complete robot arena in 3D. So I can see there is a traffic signal sign over here and all the QR codes, so I can view it from any side as I want. Okay, I can even zoom into robot. You can see all the detailed parts of the robots. And the front side of the robot is facing you in the actual camera. Okay, so here in this view, so the robot is facing downwards. So similarly, this is the front of robot. The LiDAR front is the front of the robot. Even you can see a small camera in front of the robot. So that is because this is like a cylindrical robot, so a lot of time you can get confused between the controls. Okay. So let's start with controlling the robot. Okay, so right now we will control the robot in simulation, and later on we can change the view from, like, we can change the controlling from like this simulation to a real robot. Okay, so let's go to the documentation which is there in Chrome. So I will open the Chrome tab, and there if I scroll down, so here is the command to run teleoperation. So teleoperation is like controlling the robot remotely. Okay, so I will copy this command. I will again open up a new terminal and I will paste this command. Okay, I will open up the gazebo as well. I will keep it like this, and here I will open the terminal. Okay, I forgot to hit enter. Okay, so once you hit enter on the terminal, so here you will be able to move the robot. So I takes the robot forward, comma button takes the robot backward, and J and L turns the robot left and right respectively. And also K stops the robot. So here you have to press K to stop the robot. Okay, and all these commands are given over here. You can even change the maximum linear velocity as well as angular velocity of the robot. It's completely customizable. So if I press I, the robot will start moving forward. So in the simulation as well, you can see the robot is moving forward. I can press O to like rotate the robot, but in front direction. Okay, so again I can move the robot along however I want. So this is recommended just so that you can understand how the robot is connected using our keyboard, so that you don't crash the real robot in the real world. Okay, so only for that reason we have recommended this teleoperation. Okay, so once you get gist of controls, once you understand how this robot is actually working, then we can get onto real world robot. Okay, so for that, let's stop all the commands that are actually running. You can just select one terminal and press Ctrl C to stop that command. Okay? Even this first terminal, you can stop it. Once the complete command is stopped, it will show up a message like it will show the command prompt name. Okay? So let's go on to this our documentation, and let's see what else commands are there. Okay. Yeah, so to connect to the real robot, we should start up this launch file, which is bringup.launch on the robot. Okay, so for that I will just copy paste this command, and as it is told, we have to run this in Raspberry Pi terminal. Okay, so this is the Raspberry Pi terminal, and I will paste into this terminal, and I will press enter. This will boot up the robot, and here in the camera also you can see the LiDAR is actually stable right now, it's not moving, but as soon as robot gets started, it will start rotating. You can see over here it's rotating. Okay, and this you can also see over here, whenever this green light gets printed, that means the robot is online. Okay, so once the robot is online, you also need to connect the existing PC to the robot, so we have to bring the server online as well. For that we have another command which brings up the server. So I will copy this and I will paste it over here, and I will hit enter. Let the server load properly. How much the kit will cost, we have not fixed came upon one fixed pricing yet, because we are still talking to many wholesalers and some manufacturers, so that we can get the kit as low as possible. But you can follow RigBetel Labs on Instagram, and we will be soon posting the exact price of the kit and on the Instagram page of RigBetel Labs. And even we will be hosting some early bird offer, so if you want to grab the robot at a very cheap price, so definitely go and check out RigBetel Labs on Instagram. Okay, so definitely take advantage of the early bird offer. So once the server is online, let's scroll down. What are the other commands? Okay, so now let's view all the sensors of the robot. So for that we have to start this launch file. Okay, so I will just copy paste this launch file and I will paste it over here on the third terminal. I will hit enter, and this will open up RViz, which is a robot visualization tool. Okay, and this is used to visualize all the sensors on the robot. So here you can see, first of all, you can see a camera view from the robot in the bottom left corner, and apart from that, this is the exact LiDAR view of the robot. So it's in 3D, so you can rotate it however you want. So this is the exact way we are able to see it in camera over here. And these small obstacles you can see over here, LiDAR is able to see. This is another set of obstacles, and this is the obstacle in front of it. This is the left side obstacle. If you zoom into it, you will also be able to see all the links of the robot, like all the TF of the robot. So if I hide the robot model, you will be able to see all the detailed connections, like how everything is connected to each other. Okay, and then you can even hide the TF if you wish. And this is the laser scan. Okay, so now let's try controlling the robot just like we did previously, but it was in simulation. So right now we will try it in a real world. Okay, so I will set the robot like this. We'll open up a terminal and I will open up a new terminal over here. I will split it horizontally and I will run ROS run Tortoisebot control and then Tortoisebot teleop.py. So this command is also given in the documentation. Okay, I have this like remembered, so I can just hit enter. And just like the way you control the robot in simulation, similarly you can also control it in real world. Okay, so now I will take the robot a little bit backward. So for that I will press the comma key. I will have to first click over here and then press the comma key. So the robot will move more. I can press K to stop the robot. Okay, so if your internet is a little slow, you can face some lag, but just keep in mind to keep a finger on K button so that you can stop the robot immediately. And it's okay if you crash the robot somewhere, because we have created this playground so that you can experiment on yourself. And anyways, we will be having a manual override at our place in the Tortoisebot playground, so don't worry about it. What LiDAR is this? It's a YD LiDAR. Okay, so now just the way in which I control the robot in the simulation, I can control it over here as well. Okay, so just remember to click on the terminal first and then control the robot. Okay, so I can move the robot along, and if you wish, if the LiDAR readings are moving a lot, then what you can do is you can press Z to like reduce the speed of the robot, which will reduce angular as well as linear speed of the robot. Okay, so this is how you can control the robot. And we have one more thing. So right now you won't be able to control it like this, but if you have a joystick at your home, we are making a package through which you can control your robot through a joystick. So right now I have my own joystick over here, so I can control the robot using joystick as well. So if I let's take the stick backward, the robot will move backward. This is left and right. So I can control the robot like this. Okay, so we are working on this package so that you can connect this joystick to your PC and you can be able to control the robot as well. And the exact position of the robot that you can see over here, you can similarly see it in the RVs. Okay, so I will minimize this. So the exact view of the robot you can see over here, and even the camera you can see over here. So if you wish to see the camera in more precise way, what you can do is you can stop this RVs. Okay, I will stop the RVs. And there is one more way in which you can see the camera view. Okay, so if you scroll down a little bit, so if you just copy paste this command, okay, yeah, this will open up the camera view. You can increase the size of the camera view if you wish. Okay, and now similarly you can like start up the teleoperation and you can control the robot. So I will move the robot along. So you can see all the different traffic signs that are there on the bro, how to make robot and control it with your PC, your arrow keys. So Tushar, this is the exact shape that we are doing right now. We are controlling a robot using the arrow keys of our PC. Okay, so it is definitely possible. It's called teleoperation in ROS. So you can search for any tutorial which tells you about this. And even I have done a live stream, my previous live stream, in which I have showed you how you can control the robot using teleoperation. So definitely check that out. The joystick looks amazing. Where can I? So that the joystick which I have right now, it was a limited edition joystick. You cannot get it now. It's by Zebronics. Okay. So I will just bring the robot in the actual position again. Yeah, this was the initial position of the robot. Thanks Abhishek. If you are if you like this, please book a session or book an appointment on Tortoisebot Playground. Okay. Could we add our own packages? Yes, definitely, Sahas, you can add your own packages. That's the main motive of Tortoisebot Playground, so that you can create your own packages and use it in on a real robot without actually investing high amount of prices in this. Okay, so I will stop this camera view right now, and let's move on to some other cool things. Okay. Yeah, I will even stop the server. Okay, so if you scroll down, here we can see a section where we have told how you can generate the map of your surrounding. Okay, so in this thing we have to first start the bringup.launch, which we have already launched on the Raspberry Pi. Okay, on the robots terminal we have already did it. So the second thing we need to do is turn on the server bringup.launch. I will just copy paste this command. So this was the same command which was over here, server bringup. I will start that, and the last thing which was slam, Tortoisebot slam. So once you launch this command, it will open up RViz again, but this time it will open up with a configuration that is useful for generating map of the surrounding. Okay, so I will just launch it over here. Hi, hey, this is a great idea. Thanks, Shubham. So I will press enter. Once I paste the command, it's opening up the RViz, and here you can see the map is being started generating instantly. Okay, so the green lines that you can see are the laser readings that we are getting from the robot in real time. Okay, next thing is the black lines. So the black lines are the walls that are being detected by the robot or the obstacles, and apart from that, you can see this gray area. That gray area is an area where the robot can move right now. Okay, so it's not 100% sure, so that's the reason it's gray. But the more sure the robot is about the area, the more whiter it will get. Okay, so how should we make the robot sure that it can move in that area? By moving the robot there. So we will again start the teleoperation, and we can control the robot around so that we can make the map more and more white and black. Okay, like more digital map which our robot can understand. So I will just place it like this from the top view over here, and I will start the terminal, and here I will start the teleoperation. Okay, so now here I can see that almost this area is being already been mapped, but I want to map this area. So what I will do is I will first control the robot. I will rotate it and I will make it like this, and I will make it go forward. Okay, so here you can see as the robot is generating more and more points, the map is getting more and more whiter. Okay, so now we are getting more precise map of the surroundings. So you can see this obstacle was a trapezium in shape. So right now the robot has only seen this area, so that's the reason it thinks the obstacle is in that shape. But when we move the robot in this area, it will be able to generate complete trapezium obstacle. Okay, so let's do that. So you can see it's generating the trapezium shaped obstacle right now, and you can save this map if you wish. Okay, if you want assistance while navigating, you can also view at this image in the bottom left, but I am pretty happy with this map right now. Okay, so how to save this map? So for saving this map, you need to open up a new terminal. So I will open up a new terminal over here, and in the documentation all the details about the commands are given. Okay, so if I scroll down, yeah, so this is the command to save the map. So what exactly we are doing over here is, I will paste the command and I will explain to you. So we are running a node ROS by using ROS run, whose name is map saver, and the package name is map server. Okay, and then we have to give the location of the map where we want to save it. So I am saving it like on the home folder, or I can save it on desktop. So what I can do is I can type in desktop and /map. So, and if I press enter, it will get the map and it will save it. It says done. So now if I go on to desktop, okay, so here is our map. I can open up this map, and this is being saved as an image file. Okay, and we as I am in a little hurry, so this is like just a basic map that you can get. Okay, we have already made a high definition map and we will be using that. Okay, so I will be showing you how that exact the high definition map looks like. So see, this is the high definition map of the surrounding, which you can which we will be using now for doing the autonomous navigation. The complete trapezium obstacle you can see over here, and the complete smaller triangular obstacle also you can see over here. Okay, so let's do it right now. So let's jump on to the navigation part. Okay, so before going into navigation, I will bring back robot to the initial position. Yeah, this is the home position of the robot. So now once that is done, let's get the autonomous navigation part, which is the most interesting part, which I think. Okay, and in fact, if you are starting with ROS, that's the best place where you can start with the autonomous navigation robot, and once you build that, you will be able to understand how ROS works, and all the ins and outs you will be able to understand all those. So even for autonomous navigation, we have created documentation. It's as simple as just copy pasting those commands. Okay, so here the autonomous navigation package, again the same thing. We have to start the bring up, and then we have to start the server bring up. Okay, so I think I have already started the bring up. I will again start the server bring up. So whenever you like bring the robot to the initial position, make sure to restart the server bring up. Okay, it like zeros all the position of the robot and then starts it. Okay, and for starting up navigation, we will just copy paste this command, and I will hit enter. Okay, this time we don't need terminal to control the robot, because this time the robot will be navigating autonomously. Okay, so it will open up RViz, yeah, along with the map which we loaded. Okay, so this map has certain parameters that you can tune. If you want to see the image view of robot, you can check check mark this box, and you will be able to see the image view from the robot. I will hide it for now because it's not needed. Apart from that, there is a global map as well as local map. So I will just like the green lines, which is the laser scan of the robot. Okay, you can hide those if you want. And then the local map means the robot scans around in a smaller radius and sees what obstacles are there in this smaller radius, so that shows up into this local map. Okay, so these are the obstacles that the robot needs to be aware of. And there is this global map. So right now the robot need not to worry about the obstacles over here, which are surrounding the boundary. Okay, so this is the global map. If I hide it, these are the obstacles. So once the robot get close to these obstacles, then it needs to worry about those. Okay, that's the reason those are the global included in global map. Okay, so let's start with autonomous navigation. So for autonomous navigation, it's pretty simple. You see an option which says 2D navigation goal over here. You can simply click on that 2D navigation goal button, and you can select any point on the map where you want the robot to go. And once you select the point, then you need to select the direction in which you want the robot to see once it reaches that position. Okay, I will select this position. So as soon as I give the goal, the robot will start moving autonomously and reach over there. Okay. Is there any lag or delay you experienced controlling the bot over server? If you did, how to overcome it? So no, I haven't faced any lag or delay while controlling the robot. Okay, it is like almost real time, and we have been using a high speed internet with around 100 Mbps speed. And if you are even if you are on a good fast internet, you won't face any lag. Okay, and if you are facing any lag, just keep your one finger on the K button, so you can stop the robot like immediately when you face any lag. And even we will be having the controls of the robot, so you don't need to worry if you crash anywhere or somewhere. Okay, so as you can see, the robot reaches the goal autonomously, and once it reaches, if you open up the terminal, it also says goal reached. That tells that the robot has been reached the goal. So now see, the robot is around these obstacles, right? So the robot only needs to worry about these obstacles, so it's giving highlighted colors to these obstacles. Now the robot is not worried about all the obstacles that were previously. Okay, we can give one more navigation goal somewhere around here. So now the robot will again start moving over there. So once it's close to this obstacle, it will detect it and it will move slowly. Okay. Yeah, I guess it is done now. It should show it on the, yeah, it says goal reached. Okay. If the obstacle is smaller than the robot, how would it go about it solving? Yeah, so we have not mentioned that yet, so where the obstacle is smaller than robot, but as we have camera on board, so we are also working on object detection, and that is how the robot can detect obstacles that are smaller than it, and it can avoid those obstacles as well. Okay, smaller. Yeah, yes, I guess that answers your question. Okay, so even in documentation we have given few things like what all are the packages that we have been working on, that we and along with my team we are working on those things. So if you scroll down, so here you can see we are working on QR code detection package. So as you can see on the arena, there are a lot of QR codes. So all those are Arupo markers that have been used in ROS very popularly. Even Boston Dynamics uses these markers to detect some boxes, and those robots pick up those boxes. So yeah, so we have been working on those packages as well. Apart from that, we are also working on sign recognition using machine learning. So we will be training our robot to detect home sign and left sign and all those signs that are you can see on the arena right now, and the robot can recognize those and act accordingly. Okay, that is the another package that we are working on. Apart from that, we are also working on autonomous driving car package with sign awareness. So all the complete yellow lines and the zebra crossing, the dotted lines, and all this traffic signs, they will combine together to make an autonomous driving car. and you can navigate like the complete arena. You can navigate through it as an autonomous driving car. Apart from that, we are also working on line following robot using OpenCV, which is a very easy project. So I guess it will be released within next couple of days. And there are many more projects that I've been working on. And if you have any idea with this robot, definitely you can suggest it and you can contribute to the package as well. For that, you can book an appointment at Tortoisebot Playground, which is RigBetelLabs.com/playground. You can book an appointment over there. You can work on Tortoisebot anywhere at any time. It's 24/7 available, depending upon the booking schedule that has been already booked. So you can book schedule that suits you, and you can work on the robot. You can work on its code, and you can make packages of your own and implement on real robot without actually spending any money on the hardware of the robot. Can we change the playground? Not so much, just by moving around. Yes, definitely, Sahas. So every time you book a playground, you will be appointed with the instructor, will be there with you all the time. So if you want to move any specific obstacle, you can tell the instructor to move it and he will do as you say. Okay, so if you just want a plain playground without any obstacles, you can do that. If you want to add more obstacles, you can even tell that. Okay, so yes, definitely it's customizable. It's upon you, and you can tell instructor whatever you want. Okay, so I hope you liked this Tortoisebot Playground. We have been working on this since past 1 month, and we were very excited to bring it to you because you are the people who are who like to work on ROS, but some of them don't have privilege to buy all the hardware. But I had those hardware, and that's the reason I want to give back to you, and that's the reason we started Tortoisebot Playground. So I hope you make full use of this Tortoisebot Playground, and you enjoy your like experience at Tortoisebot Playground. And even if you wish to like know more updates about RigBetel Labs and Tortoisebot Playground, don't forget to follow RigBetel Labs on Instagram. Okay, so the Instagram ID is @RigBetel Labs. You can go on Instagram, find it. Even we are on Facebook and LinkedIn, so you can follow us over there as well. And that was it for this live session. I hope you enjoyed, and thank you for keeping patience so that for the last 1 month when I didn't uploaded any videos. So, and I will be uploading more soon right now. So see you guys then. Bye bye and good night.